Okay, we need to take a little time and relook at test 18A review. This is actually the review test, so this isn't the test, but it's very much like it. I'm going to run through the problems, give you some helpful hints, so that when you go to take the test or to do the redo for the test, that you remember what it is you need to do to solve those problems. To start with, we're going to start with question number 1. Question number 1 talks about in a forest there were lions, tigers, and bears. Oh my! The ratio of lions to tigers was 2 to 3. The ratio of tigers to bears was 4 to 3. If there's 16 lions, how many bears were there? And then it says hint. First find how many tigers there were. This is a two-step problem. Okay? And you need to use a ratio box to be able to work out this problem. It says, in the forest there were lions, tigers, and bears. The ratio of lions to tigers was 2 to 3. Lions, tigers. Set up your ratio box. Okay, lions to tigers, 2 to 3. Okay? Now, it said there are 16 lions. Sometimes you got to go back to the problem a couple times. 16 lions. How many tigers are there? We don't know. Okay? So to be able to solve this problem, we have to do this first step. So we go 2 times x equals 16 times 3. Okay? So, if we take 16 times 3, that is 2x equals 48. And then we divide both sides by 2. Divide by 2. And we end up with x, which is our tigers, equal to 24. Okay? Now, that's awesome. But that just gives us the tigers. Now we know tigers is 24. We're not done yet because we're looking for bears. So, we have to go back and set up another ratio box. Okay? And this ratio box is going to have tigers to bears. So we have tigers and bears, because we're looking for bears. Now we know tigers, and we know the ratio. It's 4 to 3. Tigers being 24. Bears, we do not know what the bears are. So, again, remember up here, we did this kind of cool cross product thing here. Okay? We're going to do the same thing here. We're going to go 4 times b equals 3 times 24. Well, I believe that 3 times 24 is 72. And we still have 4b. We divide both sides by 4. And we end up with b equal to 72 divided by 4. Well, if we take 72 and we divide it by 4, 4 goes into 7 one time evenly. 4 subtract 2, 4 goes into 32. 18 what? 18 bears. And that, folks, is what we were looking for. The second is number 2. Okay? And number 2 says a shoebox was 30 centimeters long, 15 centimeters wide, and 10 centimeters high. What's the volume of the shoebox? Well, you have to remember that volume is equal to length times width times height. Okay? So, the length, 30, times 15, times 10. And, you know, there's a lot of different ways you can do it. But go ahead and do the math. 30 times 15, multiply that times 10. You will get 4,500 centimeters squared. That's number 2. Now, number 3 was a really easy problem. if you thought about it and you followed through. Number 3 says if a coin is tossed and a number cube is rolled, what is the probability of getting tails and a 1? Well, a coin, this is number 3, a coin only has 2 possibilities. You can get heads or tails. So probability of getting tails is 1 out of 2 possibilities. The probability of getting a 1 on a cube, well, a cube has 6 sides and 6 different numbers. So it's 1 out of 6. So all you have to do with probability like this is just multiply straight across. And 1 times 1 is 1, 2 times 6 is 12, and that would be your answer. So that one's pretty easy. Okay? Now, number 4, it says use 2 unit multipliers to convert 54 square feet to square yards. And I actually put an example of this one on the board yesterday. People didn't notice it, and so it's kind of one of those things you have to pay attention to. 2 unit multipliers, square feet to square yards. We're going to yards, we're starting with feet. Okay? So we have 54. And since it's square feet, you're going to say feet, feet. And I put that over 1. And then you want to go to square yards. Well, 1 yard is 3 feet. But it's square yards, so you got to have another yard. And that's also 3 feet. Okay? So now we just have to get rid of the commons, and that's easy to do. Feet, 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 feet. Leaves us with 54 yard squared. My pen is not working today very well. Over 3 times 3 on the bottom. That's 54 divided by 3 times 3, which today 54 divided by 3 times 3 is 6. And you keep the yard times yard, which is yards squared. Let's take a look at number 5. Number 5 requires us to draw a number line. And it says, on a number line, graph the negative integers greater than -4. Okay, well, I'm going to just go ahead and put some marks on my number line. And I'm going to say this is -5, and this is -4, -3, -2, -1, 0. Okay? Now, folks, it just says graph the negative integers. It doesn't say graph the fractions and the decimals and all that good stuff. It just says the negative integers. So we need to look at negative integers greater than -4. So, okay, negative integers greater than -4. Okay, so is -5, we have to think that the arrow's pointing to the right. Is -5 to the right of -4? No, it's not. Is -3 to the right of -4? Well, yes, of course it is. So we are going to go ahead and we're going to put a solid dot on -3. Is -2 to the right of -4? It is. And they're also negative integers. -1 is to the right of -4. And it's a negative integer. How about 0? No, 0 is not negative. It is to the right of -4, but it's not negative. So your answer is right there. -3, -2, -1. And they just have dots on them. There's no shading in between. Now, let's take a look at number 6. How many degrees is 1/8 of a full circle? Well, for number 6, you really need to know just 2 things. How many degrees in a full circle? Think. Yeah, 360. Okay. And if we want to know what 1/8 of a full circle is, we would just multiply 360 by 1/8, or you could just take 360 and divide it by 8. And if you take 360 and you divide it by 8, guess what? It will be 45 degrees. Okay, number 7. Now, number 7 does require a little bit more thinking. It says to diagram it, okay? And I don't care if you diagram it or not, but you got to do some thinking about it. It says Jenny bought a shirt for $32, okay? But that shirt was only 4/5 of the regular price. So, what you've got to figure out is what's the regular price. Well, 4/5 of some number is 32, and you could handle it that way. You could go, okay, 4/5 times some number equals 32. You can do it that way. Or you could look at 32 and go, well, if 32 is 4/5, okay, so I've got 5/5 here. 4/5 of it is 32. So take 32 divided by 4, and you're going to figure out that each fifth is 8. Okay? And 32 is 4/5 of that amount. So what's the regular price of the shirt? Well, that's 5 times 8, which is $40. Okay, that's pretty easy to figure out. What percent of the regular price did she buy the shirt for? Well, kind of easy to figure out if you think about it. 4/5 is what as a percent? 4/5 is what as a percent? You can take and take it times 2 if you want to. Turn it into tenths, but it's 0.8 as a decimal, or 80%. Now, we haven't talked about number 8. Let's talk about 8 just a little bit. Number 8 is it gives you a figure, okay, and it says, what is the measure of angle A? Well, I'm going to kind of dissect this a little bit. We're going to look just at this part, this triangle right here on the left. We know some things about that triangle. We know that one corner of that triangle has a right angle. So that's 90 degrees right there. Okay? We know that another corner of that angle is 40 degrees. Okay? So we have 130 degrees right there between those two angles. We know that a triangle has 180 degrees. So if we simply subtract the 130 from the 180, we will know that the remaining angle A is equal to what's left over, which is 50 degrees. Okay? Now, if we know angle A, then we also know angle C, which is the opposite of it. Angle C is also 50 degrees, which allows us to find out the measure of angle D, because we now know two angles of the other triangle, the one on the right there. We know that now, okay? We know this angle is 70 degrees. We know that angle C is 50 degrees. That's this one. All we're left with was angle D. So 0, 0, that's 0, 5, 10, 120. Is that correct? And then if we take 180 minus 120, we end up with 60. So angle D is equal to 60 degrees. Okay, the number of diagonals in any side figure has something to do with the number of sides of the figure. So we're going to just set up a pattern. Okay, when you're trying to find out diagonals in a figure, there is a special formula that you can use. If you look at this top figure, okay, and you look at the corner of it, you'll notice that you've got, let's say you choose this as your vertice. You can draw a line from here to here, but that's not a diagonal. You can draw a line from here to here. That's not a diagonal. There is no other vertice out here that you can draw a line to. So, if you have a three-sided figure you are not going to be able to draw any diagonals. So 0 diagonals. Okay. Now, if you have a four-sided figure, if I pick one corner, okay. Now I can't draw from here to here or here to here because that's the side of the figure. However, I can draw from this vertex to that vertex, and that's one diagonal. Okay. The next figure has 5 sides. So, again, if I try to go from this corner, this vertex, I can't go from here, and I can't go from here, because those are both sides of the figure. However, if I pick this corner right here, I can go from here to here, here to here, and that gives me 2 diagonals. Now remember, the figures, this has 3 sides, 4 sides, 5 sides. This has 6 sides. So what's your guess as to how many diagonals there's going to be? Yep, you're right. There are 3 diagonals because you can go from here to here, here to here, and here to here. That's 3 diagonals. Now it fits into the formula perfectly. The number of sides here, which is represented by n, and if you take n minus 3, you will get the number of diagonals. And it works for any number-sided figure. If you had a million-sided figure, it would be a million minus 3. So it would be 999,997. Now we're going to take a look at circumference. And this is actually on the back side of the review. Now you have to remember the formula for circumference, which is pi times d. Now in this case, we're going to use for pi, we're going to use 3.14. So that's what we're using for pi. So it is 3.14 times d. Diameter is, well, it says it's, the radius is 15, so the diameter is really 30. Because it's twice the radius, and the radius is 15. So you're going to take 3.14 times 30. 0, 3 times 4 is 12. 3 times 1 is 3 plus 1 is 4, and 9. Okay, you have 2 decimal points. So the circumference of the circle is 94.2 inches. Now, the next one we want to look at, of course, is number 11. Now, number 11 has a formula that you can use. And in fact, the formula was on the answer sheet of your test, but half of you ignored it. So, let's take a look at it. The formula is base 1 plus base 2 over 2 times the height. Okay? All right, base 1, it makes no difference which one you call base 1 and which one you call base 2. Base 1 can be 30, base 2 could be 20. 30 plus 20, that today is 50. Divide that by 2, okay? And then multiply it times the height, which right here looks like is 20. So you have 50 divided by 2, which is 25 times 20. So 25 times 20, 0, 10, 4, 5. Okay. Here we go. So that means that if you take 25 times 20, you end up with 500 millimeters squared, and that's the area of that trapezoid. Okay, the next one we're going to look at is number 12. And number 12 is fairly easy. It says find the missing exponents. And if you remember our work with exponents, if we multiply exponents, we simply add them. So in this case, we have 2 to the 3rd power times 2 to the 4th power. The bases are the same, so we have 2 to the 3 plus 4 power, which is 2 to the 7th. Done. That's number 12. Now, number 13, we have a table. Okay, and number 13 is one of those that I've said, we're going to see them all year long. The fraction and the percent is what's missing. We actually have the decimal, which is 0.04. And we want to know what the fraction and the percent is. Well, if you read this out loud, you will remember that this tenths, hundredths, this is actually 4 hundredths. 4 hundredths means 4 over 100. There's your fraction right there, unless you want to reduce it, which is kind of nice. So if we reduce it, 2 into 4 is 2. 2 into 100 is 50. We could reduce it one more time, and we could go with 2 goes into 2 once. 2 goes into 50 25 times. So the reduced fraction is 1 over 25. Now, as far as the percent is concerned, okay, the percent is simply you take your decimal, whatever it is, no matter whatever it is, and you are going to move that decimal point 2 places to the right. Okay? So now we just simply have 4%. And that's the percent. Okay, we're going to look at number 14. Number 14 is a really easy one because it's just talking about percent of a number. And we have done these quite a few times. It just says what percent, WP, of means multiplication, 200, means equal, 80. Now, we know this is a pretty easy one because we know that we can just go through and divide to find our answer. Divide both sides by 200. Now, one thing we should realize, though, is that we have extra zeros here. So what we really are doing is we're taking 8 and we are dividing it by 20. We put in our decimal place. Add a 0. 20 goes into 80 4 times, and that is evenly. Okay, subtract. So we end up with what percent is equal to 0.4, but we have to turn it into a percent, and when you have a decimal like this, then we have to go 2 places to the right and add your percent mark, and so it is indeed 40%. Now, we're going to take a look at number 15. Number 15 uses a ratio box. Okay, and in your ratio box, you're going to have your percent, and you're going to have, I'll put A for actual. Okay, you'll have 3 parts because you have to have the 2%, and then you have to have your total, which of course in the percent column is going to be 100. It says use a ratio box to solve the problem. 45% of the 3,000 fast food customers ordered a hamburger. How many did not? And they want to know actual numbers. So if 45% ordered, we're going to have ordered, and then I'm going to put an O with a slash, which means not ordered. So 45% ordered, and we know that there's 3,000 customers. Okay. Now, we should be able to find this by simply just taking 100 minus 45. And if we do that, we will find out that that number is 55. Now, we don't know the numbers on the right-hand side here. We don't know these two numbers. But in all actuality, it only asks us how many did not order a hamburger. So we really don't need this up here, and as a result, I'm just going to draw a line through it. We don't need it anymore. And this is going to be our x, and that's our variable that we're looking for. Now, if we would just use cross multiplication, we could solve this. We'd end up with 100x, or 100 times x, equals 3,000 times 55. Okay, and you're going to end up with 165,000, but you have to divide that by 100 from over here, and you're going to end up with 1,650 customers, and that's what's going to go right there. All right, we need to take a look at number 16. And number 16 is simply multiplying and writing the product in scientific notation. So we have 2.5 times 10 to the negative 3, and that's times 4 times 10 to the negative 5, I think. Gosh, it's kind of hard to read on here. Is that a negative 5? No, it's a negative 6. Okay, we'll rewrite it, and if you remember, we can do this because of the commutative property. We can take these two and those two and put them together. So we really end up with 2.5 times 4, which is 10, times 10, if we remember, negative 3 plus negative 6 power, which is 10 to the negative 9. Now, we are not done. We are not done. And the reason we're not done is because this right here is not scientific notation. It's not the right way. You have to write it as 1.0. There can only be one number to the left of the decimal. So 1.0 times 10 to the, well, we have to move it 1 to the right, which takes 1 away from that negative 9 and actually makes it a negative 8. Okay, now we're going to take a look at number 17, which is a pretty straightforward problem. We have 1 and 2/3 y equals 75. The easiest way to handle this one is probably to turn it into an improper fraction. So we take 1 times 3, which is 3, plus 2, which is 5, over 3, y equals 75. Okay. Then probably would be good if we use the reciprocal over here so we could get y by itself. So we multiply both sides by 3 over 5. Okay, and then we would cancel these out, and we end up with y is equal to 75 times 3 all over 5. Okay, well, we know that we can get a 5 out of 75, so if we take 5 out of here and 5 out of here, now 5 goes into 75. 5 goes into 7 once, with a remainder of 2, and I think that's 15, times 3 gives us 45. So y is equal to 45. Okay, we've got 3 problems left to deal with here, and these shouldn't take very long. Looking at number 18. Okay, number 18 is 12.5 equals 1.25 plus f. Now, to be able to solve this, we really need to line up the decimals when we subtract, because we're going to have to subtract 1.25 from this side, because we want to get f by itself, and we have to subtract 1.25 from this side. Now, you're going to have to add a 0 up here, because the worst part of this problem is having the decimals line up. So, when we do subtract we end up with 2, 5 over here. Okay, and we end up with 11 over here, which makes it really a pretty simple problem, and that is the answer. Okay, the next problem that we need to deal with is problem 19. And it isn't all that hard. It's not that tough of a problem. It's just a matter of remembering to use the commutative property. We have 2AB, and we're going to multiply 2AB times negative 3A squared B. Okay, now the commutative property tells us that we can mix up the order here. And let's do that. We have 2 times 3, so we'll write 2 times 3. Okay. And then we have A times A squared, so A times A squared. And then we have B times B. Okay? So 2 times 3, 6. A times A squared, A cubed. And B times B, B squared. And that, folks, is how that problem looks. And that is problem 19. Okay, the last problem, and we'll do that one in green so it's a little easier to see, is mostly a PEMDAS problem. So we're going to write PEMDAS. Remember what PEMDAS means. Parentheses, exponents, multiplication, division, addition, subtraction. Okay, so we have negative 3 minus the quantity positive 4 times negative 2 minus the quantity negative 2 times negative 6. Now the other thing you have to remember are the rules for multiplying with negatives. Remember, and I'll just put this over to the right so that you can have it, and this really needs to go in your notes if you don't already have it there, that a negative times a negative is always a positive times a positive, or a positive times a negative will always be negative. And of course, a positive times a positive is a positive. Okay, so let's go back over here. We've got negative 3. We leave that the same. And then we say minus, and then we have 4 times a negative 2. So that's positive 4, negative 2. So negative 8 minus, okay, we have negative 2 times negative 6. Well, if we remember right over here, a negative times a negative is a positive, so a negative 2 times a negative 6 is going to be a positive 12. Okay, so that's positive. I'm leaving it in the parentheses so you remember that we're just doing the multiplication first, and then we'll go ahead and do the last part. Okay, now we have negative 3 minus a minus. Well, if we minus a minus, that's like taking a negative of a negative, which makes it a, that's right, a positive. So we have negative 3 plus 8 minus 12. Negative 3 plus 8 today is 5 minus 12. And 5 minus 12, we've got a negative 12, positive 5, subtract the 2, take the sign of the larger number, is a negative 7. And that, folks, is the end of the lecture. Now, remember that you need to take notes on the problems that you missed, and if you have the notes, you can use them to retake the test or take the test. Thank you. Have a great day.